Okay, so we're gonna move on here. Right now, we're gonna do task 2 virtual IR lab. So I guess I'm just gonna stop at the final task because like the final task needs me to implement some new functions, like designing new functions. So that is more than information seeking, and I will stop after I learn like how to use this tool. Okay, so all right, let's go. Uh, let's first we just go over this part. It's for you to understand. So major task is to implement a basic retrieval algorithm with a okay. Go to some browser, right? Not secure. Okay, doesn't matter. Okay. Read the tutorial carefully before the start. Tutorial landing page. Okay, so let's first go there and open that up. Assignment 2, see the Lampard tutorial. Okay. So that's an overview, quick guide. Computes the relevant score of the document. A simplest example can be shown as follows. Okay, it says the relevant score is summing out the occurrence of the function as follows. Score. So, as summing up the occurrence of all correct terms in the documents. Okay, note that for occur means that for each the occurrence of team I, the current document score. So for every occur, you are adding 1 point. Okay, let's consider another trivial functions. Could be written as this. So we can in the virtual IR lab as follows. Double this for all score. Okay. Note that the variable that specifies that mu in the okay. Trivial function. Okay, so we're gonna go through this, I guess. Create function. Okay, so this is create function, how to manage a function, create a search engine, leaderboard, and summary. Okay, wonderful. All right, so the way I'm doing this is that I just go through like every section, like how every section is written out, what's what, and then like when I'm gonna use it later, I just go over here and search up. Okay, gonna ignore this because I'm not early bird anymore. Okay, build your own function 2.1. Okay, 2.1. Build a retrieval function. First thing you're gonna do is to which gonna be used. Do this by clicking on the create function. Okay, let's create a function then. Okay, let's first log in. Oh shit. I don't know why. They just keep register on the right hand, which doesn't make any sense. Okay, let's create a function. First thing you're gonna do this by clicking. In general, you need a function that computes a score. Where are terms in query Q, that is a relevant score with respect to query the sum of each curve we have. already implemented BM. Yeah, function for you opens up by selecting and click open. Read the code carefully, understand how such a retrieval function is implemented. You may find it helpful to review this function in our slides. Okay. Okay. Let's look at this. So double type B this. Actually, I really don't know how this means. Actually, let's look at the slides though. We should have that. Okay. It's basically the same thing though. Okay. So this is BM25, state of the art. Many. Okay. So times 1, this is T weight, this is weight, this is IDF. Okay. Useful when this isn't much helpful. Okay. For occur. So for occur. See. Let's just kind of like how this log into this. So CTD plus 1. CTD is basically this. And then DFT is DFI, and doc is doc, then times 1, log is log, times it's the same thing here. Okay. So QF, TQ is QF, and then this is TF. Turn frequency I and quartering frequency I. Okay. Okay. Turn frequency for each quarter term is document frequency, quarter term frequency. Okay. So I guess all of these can be, but I'm not sure about that. Okay, IDF double weight, and then score will be this, right? Okay, we have basically 3 different things. I'm not sure how to do everything. I still don't know how this means though, but anyway, just gonna go through it. Okay, implement a new retrieval function. So we're gonna do this. This looks exactly the same as this one though. Okay, so we have this here, and I want the code. I don't want the code of this on the side. Yes. Okay, good. So this is a code and this is a function. Let's see how everything translates. So for cur double IDF is log Okay, this is IDF. Okay, log of ndoc ruby doc n minus dfi plus 1.5, and nothing happens here. And then dfi. Yeah, this is pretty simple. And then there comes the weight. Weight is, okay, now it becomes a little bit complicated here. Let's see, weight slash, so we're having a k1 plus y. Okay, k1 plus 1. Yeah, we have the k1 here, but for some reason the k1 is here. Okay, we're gonna ignore that first. K1 plus 1 times, okay, this. Okay, and then it comes K1 times, because K1 is also here, times will be Y. Okay, this is Y, this is okay. And then, about this though, K1 is, okay, so we have a B here. This is B. B just times this, so it's B times the length of D. Yeah, this is correct, but it has to be minus B for some reason. Okay, okay, I'm a little bit confused here. I don't know what's happening. Okay, times, okay, so it's times this, but it's 1.0 minus that. Okay, so if we kind of, if we kind of do this, then it would be, we're just gonna expand whatever this is, 1b of length b times length. Okay, it should be over the average, and then it will be minus b. Okay, so it should be something like this. When you expand this, but this is basically saying something like y minus b plus b times length over average when there is no parentheses whatsoever. Y minus b. Oh yeah, this is the same. Okay. I don't know why it writes this way, but I guess it's fine. Okay, and then t weight will be k3 plus 1, and then yes, yeah, because that's that. So QFI, yes. Okay, so we have a little bit of a cheat sheet here, I guess. Okay, so we can see B is, so constants can be tuned. Okay, so we can tune the constants. So the constants can be whatever. Okay, that makes sense. Okay, now I understand. So this is for, yeah, when you have this, is for all, but this will be for every occur. Yeah, because it's for every t though. And this for every I to k. So that would be for all, and this is, I don't know, probably. I'm a terrible coder. Okay, okay, I guess I'm just gonna copy and paste here. So I'm gonna go over it later, but right now let's implement this into that. It looks like the, yes, pivoted lens normalization, yes, but not like that as a mid-pair moment. So it's TFI, so the new retrieval function is actually crossbreeding. Okay, name of function as new pivoted. You have a parameter in this function, specify for this between 1 and 0. So that you can take now. Wonderful. Okay, so let's look at the pivoted normalization function. Occupy. Do we have a pivoted normalization function in these slides? No. Okay. Pivoted vector space models. It's called vector space models though. Okay. Okay. So what is this function called though? They look exactly the same though. No, not really. Okay. Let's go to the sides and see if any of them have called a pivoted. Pivoted. Am I spelling this right? Pivoted. Yes. Okay. For us. Okay. But this is still BM5 though. You can see. Okay, pivoted lens normalization. Yes. Okay. Wow. This is what it is. Okay, so this is what it is. Okay, so we have this now. We have the pivoted lens normalization. Okay, we have this, and so we go to the, we go here and we see, okay, double S. For occur, this is what this means. Score is so we have basically we should have 3 parts times. Actually, let's put them in the notes so we can see more clearly. We have the parentheses. So this is 1 parentheses. So this is 1. 1, 2, 3, 1, 2, 3. Yes. Okay, let's do that. And then okay, so this is another one times QFI times this. Okay, wonderful. So, okay, okay. I'm guessing this will be, this is this. Let's see, s times stock length. Length times y minus s. Okay, yes, this is exactly this. And then this is that, and then this is this, and then the square, and this is this. Yes, wonderful. Okay. Now, as we understand this, let's do this again. So, okay, so what function are we using right now? Okay, so let's move this to here. Uh, let's move this to here, actually. Okay, so we can see it. Okay, see what's the difference. Okay, so here it's different, and then this is different, this is different, but this is the same. Okay, let's name it, what's the name? New pivoted. Okay, new pivoted. You have a function b, but okay, so let's call that b, and then specify a few functions. 0.1. Let's leave it as it is and add 1. Okay. Okay, so I'm gonna change these sentences later, but the rest of it will be fine. And then let's change this. So in here, this is this, but in here is 2 times ZTD. Okay. We can see this is TD, not TQ. And then TD. Yeah, we have TD here. So basically, you want inside of this 2 times TF. Let's see if, yes, TFI. And then whatever over here, it will be, okay, CTD will be TFI plus TFI plus 1 plus yeah, the rest will be the same. So instead of S, we change it to B. Then I guess we are good. You pivoted. Successfully adds a function. Okay, should be your code that implements the function. Okay. Okay. The code. Okay, 2.2. Save this. Evaluate. Now that you have successfully implemented intro function saved it, you can manage your function using the manage function link on the left panel. Here you can show, edit, evaluate, and delete function you wrote, as well as find your function and click on evaluation. Let's do that first. So manage function, you can say new pivoted, click on evaluation. And click on, you will see a page where you can test performance ranking a few large or diluted system. Okay, and so on. For every collection, you can evaluate a function using any, provided it may take a few minutes when you click the evaluation button. Using any is approved. Okay, it might take as we are running the function as well. Once it's done, you can see the mean average precision and P30 metrics. Specify 9 value pilot plot the performance curve using against on the DOE collection, report the best performance of new pivoted. Plot the original we provided on you. Printer as some report. Okay, so let's do the two plots. I guess we're kind of down here. So I'm just since like I've already done everything with how I do my information seeking. Now I pretty much know how to do everything, and then the last part would be the design your own function. So yeah, I guess I hope this is enough for your resources. Okay, bye bye.